Projectile motion part 1. First of all, we need to define what a projectile is. A projectile is any object in free fall. Oh, we're going to ignore air resistance because air resistance is yucky, so we will assume that we're always falling in a vacuum. We looked in Physics 11 at one-dimensional projectiles, but now that we've learned a little vectors, done a little trig review, we can handle two-dimensional projectiles. Question number 1. Suppose I have a mass held at shoulder level and I fire it horizontally. You know what? Let's pretend it's my Nerf dart gun. And I make sure that it's exactly level horizontally. And let's also assume there's way more air in here so that it's not just it's gonna go. If I were to pull the trigger, what path would it trace out? We have 4 options, and you know what? Since there's an election coming up, we're going to vote. Path number 1 is that path right there. Path number 2 is that path right there. Path number 3, it goes straight for a while and then falls down. Path number 4, it goes straight and then goes straight down. Those are the 4 paths I'm going to ask you to pick from. So if we were to fire a projectile horizontally, we're ignoring air resistance, what path does it trace out? A or B or C or D? Once again, how high you hold your hand up is how sure you are of the answer. Who says, Mr. Dueck, it's going to trace out path A, Mr. Dueck? It's going to come straight down, path A. Well, that's not bad. Is that a vote, Ben, or not?
No, I don't think so.
Who says B? 1, 2, 3. Ben's confident as well. Who says C? It goes straight for a while and then drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Who says D? It's going to go straight, come to a stop, and then go straight down. Who didn't vote at all and needs to vote and tell me which one they're going to vote for? Which letter? C? Convince me. So what you'll often hear me say is you can attack or defend. You can attack someone else's answer as that must be wrong, or you can convince me that your answer must be right. Convince me. Dan, are you attacking or defending?
Defending.
Okay, what answer did you pick?
So I answered B.
Yep.
And then the reason I picked it is because when you throw it forward, gravity applies immediately.
You mean gravity doesn't take a while before it realizes the object is moving and then starts to act? Gravity acts right away, so objects don't travel straight for a while and then start to fall. They start to fall right away. You are correct. C is by far the most common misconception, and it's not completely your fault. That's video game physics and movie physics. Movies, for example, have taught you that bullets magically travel in a straight line. They don't. Bullets are always arcing downwards. It's just movies don't show that. And bullets travel for such a short amount of time that the vertical drop maybe your eye doesn't spot. But any projectiles, as soon as they leave a horizontal cliff or a horizontally fired gun, they are falling right away. So if we want to defend an answer, you can write that. Option D, we used to call that when I was growing up Roadrunner physics from the old Coyote and Roadrunner cartoons, because the coyote would run off the cliff, come to a stop in midair, and would float for a second, and only once they realized that there was no cliff beneath them would they fall straight down. That's cartoon physics, that's not real physics. But that option C, a lot of you went with. That is absolutely incorrect. Okay? All right, next thought puzzle, and once again we're going to vote. Suppose I have 2 identical objects. They're going to start at the same height above the ground. Object 1 is released, it's going to fall straight down. Object 2 is going to be fired horizontally with a velocity. They're both starting at the same height. Which one hits the ground first? A, object 1, because it's going a shorter distance and has a more direct path. B, Object 2, because it has a bigger initial velocity. Or C, they both hit at the same time. Ooh, Kira's smiling. Mr. Dueck, these aren't easy. Oh, no, they're not. I'm trying to get at the depths of common physics misunderstandings. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer, but you must vote. So you got the idea? Who says A, Mr. Dueck? Object 1 is going to hit the ground because it has shorter to travel. 1. Who says B, Mr. Dueck? Because object 2's got a bigger initial velocity. Who says B? You're going B? Yeah. Okay. 1, 2, 3, 4, 5? 6? Always a late straggler. Who says C? They both hit at the same time. This is interesting. Lots. Put your pencils down, look up. Now, why is that? The key idea for projectiles, Ange, is that the horizontal, whatever's going on, and the vertical, whatever's going on, are completely independent of each other. Both of these are doing the same thing vertically. They're both following the same vertical distance. Their initial vertical velocity for both of them is 0. I know one of them has a horizontal velocity, but its initial vertical velocity is 0. And they both have the same vertical acceleration, which you all know. What's the vertical acceleration under gravity? It's both accelerating at negative 9.8, so they'll both end up with the same time. I don't care about what's going horizontally. That's completely independent from what's going vertically. So if you want me to answer this, they have the same dy, vertical displacement, same vy initial, same ay, so same time. You could solve that using d equals vit plus a half at squared. You could write a longer explanation, but I tend to abbreviate. Okay. So again, the key idea to realize is that the horizontal and vertical components of a projectile are independent. They don't affect each other. And so what you're going to hear me say over and over and over and over and over, Sam, is don't you dare put a horizontal value into a vertical equation. And Erica, don't you dare put a vertical value into a horizontal equation. You're going to be tempted because you won't know one of the values. And so rather than try and calculate it, you'll say, maybe I can use one from over there. No, they're independent. That's key idea number 1. Key idea number 2. What's the horizontal acceleration for any projectile? Our key idea then is our horizontal acceleration is always 0, but that's way too much writing. What's a good letter to use for acceleration? What's a good letter to use for horizontal? What's a better letter to use for horizontal? You can write this. AX is 0. Oh, what's AY? What's the vertical acceleration? You all know this from Physics 11 because I threw it at you a trillion times. Negative 9.8. We're going to call these two concepts, I call them our physics no-brainers. And what I mean by that, Ange, is if you give me a projectile question, I write those down without even thinking about it because those are always true. That gives me 2 values. Okay? It would be wonderful if I had a better way to show you this, and I will. Ben, you had a question?
What if you just, if you kept walking it through just a little higher, wouldn't it actually end up behind?
Can you hold that question? I have a video. If you were to look at, turn the page, yours is not in color because I can't print in color. This one is. Kathy, if you were to look at, for example, a projectile that had been shot horizontally off of a cliff, and if you were to look at a strobe photo where it flickered, let's say, every 1/10 of a second, what you would notice is horizontally, each of the distance vectors stayed the same, and that's because there's no horizontal acceleration. You would notice vertically the distances would be getting bigger and bigger and bigger, and that's because there is a vertical acceleration. It is speeding up vertically, but it's going at a constant speed horizontally. And Ben, I haven't forgotten your question. Patience. It's a good question. Okay? The key ideas, and you're going to have to, right now, take my word for it, but I will convince you of it. Horizontally, what's the acceleration, Liam? Vertically, what's the acceleration? Okay? So, if we're actually looking at both velocity components, horizontally, the Vx just stays the same length. Vertically, your speed does increase. And so if you wanted me to add these two vectors together, how would I add these two vectors together? I would draw them. So right at the top, if I drew the velocity vector, it would look like that. In the second location, it would look like that. In the third location, it would look like that. And so what we're saying is the projectile itself, if you want me to talk about its slanty velocity, which I don't like because that's yucky math, yeah, that's getting faster and faster and faster and faster and faster and steeper and steeper and steeper and steeper and steeper. But the reason it's getting steeper is not because of the horizontal, that's not changing. It's because the vertical component is getting longer and longer and longer, giving you a longer hypotenuse. Ben asked a good question. Put your pencils down, look up. It says give reasons for your answer here. I'm not going to worry about that. Instead, look at example 4. We're going to be looking at 3 main types of situations, 3 main types of two-dimensional projectiles. The first type is if we launch, don't write this down, if we launch a projectile horizontally from a cliff. That's the easiest. The second is going to be if we launch from the ground at an angle. Did I say angle? Components. The third is going to be when we launch from a cliff at an angle. And that's going to be the most difficult we'll deal with. But we can deal with it. So here, we're launching, this is a side view, we're launching at a velocity v at an angle theta. We would break this up into components, horizontal and vertical. The horizontal component won't change at all. So if I wanted to draw in the vector component for Vx, I would draw an arrow right there, the same length as the Vx at the beginning. Draw that in. I would draw an arrow here, the same length as the Vx at the beginning. I'm eyeballing it, Ange, but I'm trying to make it the same length as that one right there. So that's what you want to try and do on your paper. Because the horizontal component, Beatrice, doesn't change. If I were to draw a Vx right here, it would be the same length. If I were to draw a Vx right here, it would be the same length. The horizontal component of velocity doesn't change because horizontal acceleration is 0. Erica, is vertical acceleration 0? No, it's negative 9.8. So that's going to change. So I'm going to do that one in red. Right when we leave the ground, we're traveling that fast vertically. As we go up higher, what happens to the vertical velocity on our way up? Do we speed up, slow down, or stay the same? We slow down, so the vertical component right here would be shorter than my original launch. What about at the top for a split second? What's the vertical velocity for a split second right there? 0 for a split second. And so at the top, all I could ever draw if I was breaking into components was Vx. Doesn't mean V is 0. It's traveling sideways still. But the vertical component is 0. What about on my way down? Well, now I'm going to start to speed up. But do you notice this and this are the same height? The downwards vertical component would be the same magnitude as the upwards vertical component right there. In other words, I'm going to eyeball it, but I want my downwards line, Vy, to be the same size as that one, because what goes up must come down. They'll be at the same speed, at the same height, one positive, one negative. And in fact, right when we hit the ground, our impact velocity, the vertical component on the way up will be the same magnitude as the vertical component on the way down, but negative. Right when we hit the ground, that Vy will be the same as this Vy, but negative, which also means the resultant will be the same as this resultant, But instead of 30 degrees on the way up, it'll be 30 degrees on the way down. Or instead of 40 degrees on the way up, it'll be 40 degrees on the way down. That's all a consequence of the fact that horizontal and vertical motions are independent of each other, and AX is 0, AY is negative 9.8. Here is Cliff at an angle. What would the velocity components be? If I broke this up into components, I would say, okay, that's Vx, that's Vy. At the top, for a split second, what's Vy? So the only velocity component would be the Vx, the same length as the one that I drew leaving the cliff. Vy is 0. When I get even with the launch, Vx would still be the same length. Vy would be the same length but pointing downwards as Vy was pointing upwards. In other words, when we get even with the launch, Vy equals the opposite of Vy initial. If, when we broke up that slanty vector into components, Mason, Vy right here ended up being 12 meters per second, I'm telling you right here it's negative 12 meters per second. Because what goes up must come. If you know you're at the same height, you can make that assumption. Now, we're going to keep falling. This is why cliffs are trickier. We're going to keep falling. We're going to speed up more and more and more. Just before impact, Vx would still be the same, but Vy, I'm not going to draw it that big because it's going to go into the line down below, so I'll just have to draw it as big as I can. Vy would be even larger. The resultant would be that vector right there. I'll draw it in pen instead of highlighter. The resultant would be that vector right there. You have your maximum resultant when you hit the ground, because that's the biggest hypotenuse. So again, horizontal speed is constant because AX equals what, Liam? Yep. Vertical speed is changing because AY is negative 9.8. And always the horizontal and vertical motions are independent of each other, which means you cannot put a vertical number into a horizontal equation, and you cannot put a horizontal number into a vertical equation, and that's going to be by far the biggest temptation. I like example 7, I like example 7, I like example 7. Example 7 is a nice question. We're going to finish off with example 7 for today. We're going to pick up with example 9. I guess I knew example 8 next class. I guarantee on your test, you're going to have a projectile that's launched horizontally from a cliff. That's what I like about example 7. Is this a projectile? Yes. Those of you that had me last year know that I like to give you a tool or a hook or an approach that you can use almost without thinking and then adapt it to the question. For example, for forces, this is a job for free body diagram. For kinematics, it was the DFIC, list your data, find a formula, insert. For a projectile, your tool is what I call a T-table. Can you see why I call it a T-table? Because it looks like the letter. And I'm going to break up the T-table into horizontal and vertical components. Now here, I wrote the word horizontal and I wrote the word vertical. What's a good letter to use as an abbreviation for horizontal? X. What's a good letter to use as an abbreviation for vertical? So what you'll often see me do as soon as I see a projectile somewhere off in the margin, I do that. Here I already did the table for you, so don't bother. Then the next thing that I always do is I write down my 2 physics no-brainers. I can say this without even reading the question. I can tell you that AX equals what, Liam? And AY equals what, Liam? I didn't add the subscripts when I typed this, but I would absolutely use them when I'm writing to make sure that I know that I'm never going to put an X into a Y and a Y into an X. The rest I get from the question. So now let's look at the question. It says find the flight time. Let's call that part A, and the range, let's call that part B. Typically, you're going to want to find time. This isn't meant to be a joke, but you're going to spend most of your time finding time. If they give you the time of flight, the question falls apart. Okay. I'm looking at numbers. I see a 20. What are the units next to that 20, Kathy? So it's a speed or a velocity. Horizontal, vertical, or slanty? Not slanty. Horizontal or vertical? I'm going to call, instead of VI, I'm going to make this a VX, and it's 20. Jagger, what other number do you see on this picture? Vertical or horizontal? What is it? So what am I going to write here? I'm going to write dy equals, don't say 50 because you're wrong. Because we're ending up below from where we started. How many things do I know in the horizontal column? 2. How many things do I know right now in the vertical column? 2. Not enough. I need 3 things to find the 4th, so there must be something else that I know. And there is. I know my initial vertical velocity, even though the question doesn't list it. If I launch horizontally from a cliff, what's my initial vertical velocity for the 1/1,000,000th of a second right after I leave the cliff? Vy initial is 0. That's the one that's going to bug kids. So many kids want to put that 20 right there. And then they just put a horizontal into a vertical. Kira, which do I know 3 things in? Horizontal or vertical? I'm going to solve for time vertically. Now, if they had given me different information, if it had been a different diagram, and I ended up with 3 things in the horizontal column, I'd solve for time horizontally. I'm going to solve for time vertically. Just to give myself more room now, I'm going to put a little part A. I'm going to say t equals question mark. I'm not going to relist all my data, but I'm going to be using this. I'm looking for an equation that has a VI, an A, a D, and a T in it. There is one. Good, you're getting your formula sheet out, Ramon. About time. Ben, what was your suggestion? I don't know VF. That's a bad suggestion. Don't tell me anything with a VF in it because I haven't got that listed anywhere. And that's really usually how you start to do these as a process of elimination is you don't find the correct equation. You instead say, oh, I can't use those ones. What's left? So which equation? Yep. Now hang on. Just give me the basic one first. I'm going to, just to remind myself to make sure I go vertical, I'm going to go dy equals ay t squared over 2. What happened to the VI? 0, so I didn't bother writing it. But just writing those letters reminds me, put verticals, verticals, verticals. By the way, VI won't always be 0. When it's not 0, those are the toughest questions because you can only solve for t using the quadratic formula. Using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, unless you listened to your physics 11 teacher last year and got a calculator with a built-in solver. Is that why you went on that rant last year, Mr. Dueck? Could be. Now, Jabber, how would I get the t by itself? dy times by 2, divide by a, square root, that equals time. So time is going to be the square root of 2 times negative 50 divided by negative 9.8. What do you get? If I'm typing, for my new students, if I'm typing this into my calculator, typically what I would do is I would go 2 times negative 50 divided by negative 9.8 equals, and then I would go square root answer button. I find typing a bunch of stuff in my square root sometimes is awkward, unless you have one of those nice new calculators that when you hit square root, it indents and it extends the square root line, then you're fine. But those are, I think, only the newer Casios. You get 3.194382825, blah, blah, blah. Now, I'm going to use this to find more, so I'm going to write down to about 6 sig figs. I think I'm going to round off on that 8. I'm going to write 3.19438. But since part A actually wanted me to find time and I want to report that answer, I'll also report it to 3 sig figs. I'll go 3.19 seconds. That's the answer to A. If this was multiple choice, that's what I would have for you to pick from. But Kira, I'm going to use that 3.19438 or my answer button if I need to use it later. Speaking of, what's the second thing it wants me to find? The range is the horizontal distance. You know what? Another way to write that, Kira, with less writing, would be to say that part B wants me to find dx, the horizontal distance. Is that okay? Problem. In the horizontal column, I only know 2 things. Or do I? Sorry? VF is not 0. I assure you, if you stood there and let this hit you in the face, it would hurt when it hit you. If VF was 0, it wouldn't hurt when it hit you. I assure you, you would not want to get hit by this projectile. That's a bad guess. Oh, after it hits the ground, which is not what we're looking at, then it might be 0. I don't care about that. Yeah. Why can I put time in the horizontal column? Because time is not a vector, it's a, so it can go in both. And that's why I said you're going to spend most of your time finding time. Or if the question gives you time, it falls apart because you can put it in both columns and you can probably solve the question either horizontally or vertically. So I'm going to add time up here, 3.19438. And Kira, I'm looking for an equation that has a V, an A, a T, and a D in it. There is one. Turns out it's the same equation, isn't it? It's D equals VIT plus a half AT squared, only this time A is 0. So it ends up becoming dx equals VXT. And I'm putting the x's there just again to remind myself, don't you dare put a horizontal into a vertical. By far the most common mistake, kids do this. Plus 1/2. They put the negative 9.8 in because, oh, they want there to be an acceleration. We're using that equation. We must have an A. There is an A. It's a nice number. It's 0. What was VX, Kira? I've scrolled down. Oh, sorry. I erased the whole thing. What was VX? What was time? I'm going to write 3.19, but I'm going to use my answer button. 20 times answer button. And I get 63.88. You know what? Now I'll go to 3 sig figs, 63.9 meters. So if you give me a projectile, my strategy is going to be T-table. AX is 0, AY is negative 9.8. I can write that. The rest I'll pull from the question depending on what information they give me. Don't put a horizontal into a vertical. Don't put a vertical into a horizontal. You'll often be finding time by using D equals VIT plus a half AT squared. Often. Your homework, there's 15 minutes left. You can work on the take-home quiz. If you want to get a head start, I haven't finished this lesson, but if you want to get a head start on, when do I see you next? Wednesday, I will be assigning number 1. I will also be assigning more, so don't hand this in. But if you're wanting to get a head start on the homework because you think, oh, I'm going to be busy next week, you can also try tackling number 1. Otherwise, the take-home quiz is your homework.